Hello everyone, and in this tutorial we're going to make this random spider walking thingy. So this is going to be the final result, but we'll start off with making just one. Okay. So this is cached. This is not playing in real time. So the real time version is this, which is not bad. Like this is about, I think about 8 or 10 spiders. Okay, so let's get started. So this is not, we're not using KNFX or anything. It's just a SOP thing. So I'm going to start off with, so the initial version that I did was basically just walking on a flat surface, so this is the initial version that I did. And what we're going to do is we're going to use this as a base, but I wanted to walk, on any kind of a surface. So we just have to, so in order to do that, we have to make like a few minor adjustments. All right. So, okay. So I'll start off with, we'll start off with the sphere. So I'll just take this and I'll do like, Control C, Control V. And so I have this sphere and we're going to walk, over that. Okay. Now, it's not like 100% foolproof. Like it will walk on any surface, but the legs do tend to intersect across corners or like really thin surfaces. So I haven't really solved that. So you can sort of figure out how to do that stuff. Okay, so let's do one thing. First, I'll just take a circle and I want like a point to go around in a circle. So that will be our base for this. Okay, so I'll just take like this guy and I'll make it like big enough. So it's like around this and I'll give it some points. I'll make it like slightly bigger. And then what I want to do is I just want to take an add node. I'll create one point. So this will be this is the head. I'll do a path deform and I'll just make it walk. I'll just make it go around this. So this is it. And I just want to like animate the curve position. So that is what we will get. So I'll just do like alt click and I have like let's say 150 frames. So from 0 to 150, it just goes like that. So we have this dot which just, does this. And I can add some more points to this. Let's make it like 500 points. So it's like really smooth. Yeah. So the next step, so the trick essentially is that we're going to scatter some points on the sphere. And based on where the head is, it will select a certain set of points and just connect lines to that point. And that will look like it's walking. Okay, that's pretty much what we're doing. Now, one of the things I want to do is I want to be able to control the distance of the head from the sphere. And we can do that by just generating some normals and then using a peak to sort of move it closer and further away. So I'll apply some normals to the sphere, keep it at point level and then just do a transfer. So do an attribute transfer. And we're going to transfer the normal. So you can see like, let me just press D. I'll come to guides and increase the normal. See, so now we have like the sphere normals have gone to this. Let's give the sphere some additional points. Let's make it like about 50. 50 is too much, I think. Okay, 30 should be fine. So the advantage of this is that I can take a peak node and then I can just sort of, move it closer or further, and it's moving in the normal direction. So you can use any object and it will move in the normal direction of that object. Okay, so now let's do the second step, which is we want to scatter some points on this. So we'll just take a scatter and I will keep the normals and I don't want these many, I'll take about 300 points. As many legs as you want and as many legs you want like in a closer area, the more points you'll need. Okay, so this is fine. Now I also want to give these points their point numbers, like store the point numbers. So just take an enumerate node and the enumerate node will allow us to like keep this at point level and the attribute is fine. So if you look at it, if I do split left right and I look at it from like a geometry spreadsheet, you will see that we have the index value, so which is like 0, 1, 2, 3, 4. So it's storing the point numbers. This will be useful later on when we need to connect the points together. Now, based on this point, like our main head is where we want to select, our base points over here. So let's make this a little higher. Let's go to about 500 for now. And so we do a mask from geometry. and this comes in here, that goes in there. Press enter, and oh sorry, yeah, just change this to points and that should work. There we go. Okay, so just increase it enough. Okay, so those are the points that we're selecting, except I want like a certain area to be like pretty hard, so I'll just take it like this. Yeah, so you can just increase that to how many we want. Yeah, there you go. So this is good. These are the number of legs that we will have. Okay, now just take a blast and we're going to get rid of everything else. So just take a blast here, set this to points, and we'll do like at mask greater than 0.5. Okay, sorry, less than 0.5. There you go. Okay, and you can see like, there you go. So those are the legs that we are going to generate. Now this still has the normals. So what we want is I want like 3 points, right? So I want the head, and then I want like a knee, and then I want the leg or like the foot. So I'm just going to take this, I'll do a peak, and I will push this out a little bit. So see, so this is, it generates a distance, and then I'm going to take a transform and I'm going to scale this down, but we want to scale it down from the center. So take the pivot and set the pivot to like the center of the geometry, which is like we do $CEX, $CEY, and $CEZ, and that will make sure that it's in the center, and then we'll just scale it down. So we have like 2 sets of points. So we have like the base and we have this, and the peak will allow us to give us some distance between, you know, like those two, and then we can merge these together. So this comes in here and that goes in there. Now I just want to connect everything together. So take a for each. So we can do a for each point, but we want like, since this has the enumerate value, like it has the index attribute. So based on whatever points have the same index value, those should come into the for each. So what you do is you come in here to the end and you say piece attribute is index. And when we connect this, it should give me 2 points. There you go. And let's just look at it from a numerical standpoint. So it's 0 and 1. And then we do a merge and we get in our third guy here. Okay, so this comes in here. Let's just put a null over there. I'll call it head. Yeah. And that comes in. So it will be 0, 1 and 2. So like that. See, so like this. And then just take an add node. And we don't have to do anything, just do like by group, and that's it. And then we can do a resample to make it slightly smoother. Yeah, that's like way too many points. So let's lower that. And then we'll do another resample and we will make it subdivision curve. So it's kind of rounded off. And that's it. Like if I look at it now, and if you press play, you have your walking spider. So it's pretty much that simple. So it's not really like the most complicated thing. And then the nice thing is, based on how many points you generate, so I'll just take the scatter and color it, and I'll take the mask and color it. So based on how many points you generate, you get more legs or less legs. And based on how much distance you give here, you get like, you know, a larger spider or a smaller spider. Of course, if you're going to generate multiple spiders, it will get slower when it has to generate that much, but that's fine. Okay, so now let's just, you know, detail it up a bit. So what I want to do is, I want to give it some noise, but I don't want the legs to move. So I'm going to take a resample node and just, we don't want to generate any points. We just want to generate a curve view value. Okay, so the curve view is going to generate, you know, like a gradient. So it will be like 1 here and 0 over there, because that's where we are starting the curve, right? So it's 0 to 1. And then just take a noise value. So we can do attribute noise vector. And yeah, the vector will be position. We will plug this in. Like increase the element size. We don't need the fractal at all. So just turn that off. And in the blend, we will pick up use attribute and type in curve view. See, there you go. So we get this. See, so what's happening is like the legs, those stays where they are supposed to be. and we get like a nice little sort of wavy movement on the whole thing. Okay, so you can sort of define like how much you want and how much the whole thing should be wavy, but there you go. Yeah, so it's not bad. Okay, so this is done. Now the only thing is I want to do two things. One is I want the legs to sort of, like right now they just sort of appear and disappear, but it would be nice if they kind of form, right? So we can use a carve to sort of like cut the curves as they sort of move closer or away from the foot. So what I can do is, it has the mask value, right? So if you look at the mask value, you'll see like the closest curves are red, and then the further away curves are like yellowish. So what I would like to do is I want to promote the mask value to a primitive. So I'm going to take a promote. So take an attribute promote, set the method to maximum, and we're going to go from point to primitive, and this will be mask. And what that should do is this. See, so all these curves are completely red, and then these ones kind of fade out. And if I take a carve node, and this got added in like Houdini 20 or 20.5, where you can carve based on attribute. Okay, so if I carve to attribute and call it mask, this is what we'll get. See, so you're getting like, so it's cutting in the wrong way. We don't really want this, so it's very weird. But what we would like is that it should cut, like the outer one should cut and the inner one should be fine. So we got to like reverse this value, because what is happening is like this is at 1, right? And these ones are cutting like completely. Okay, so like if I set this to constant, see, so what we want is like this, but like these ones should be more, like the inner one should be more solid, but right now the inner ones have a value of 1. Okay, so those ones get cut completely, and the outer ones remain fine. Like this is what is happening right now. So the outer ones are fine, the inner ones disappear completely. So what I'll do is I'll take a remap. So take an attribute remap, and we want to go from mask, and we'll just call it, say, cut, and this will be at primitive. And all I do is I just flip this. Okay, and if we come to carve, yes, change this to cut. See, so what is happening is, see, so those ones are fine, and then the other ones, like the outer ones, sort of start forming as they come closer. So if I press, let's just do a null. See, so what you're getting is, see, so those legs sort of form as they come closer, and then they disappear. So it's, it looks more natural. I'll turn this off. Let me turn on the curve view for now. See, so it looks like it's like it's forming its legs as it sort of gets closer or further away. So it looks more natural. Okay, now the last thing we need to do with this is I would like to give it some thickness, but that thickness should also be based on the mask value. Okay, so let's take the mask value and bring it back. I can take a promote again. So take an attribute promote, and we'll go from primitive to point and call it mask. So our mask is back, and we want to use this for p-scale. Okay, so the inner ones are thickest and the outer ones are thinner. Or let's try to make this to minimum. No, it'll be the same value. It won't matter. So I can take a float. So take an attribute, just float, and we do set always, set this to p-scale, and I can do a remap attribute and mask. Okay, and now what will happen is if I do a sweep and I'll do a round tube, see, okay, so this is happening because I think it has normals. So just take a delete, take an attribute delete, and get rid of the normals. There you go. See, so now what is happening is because of this p-scale, the outer lines kind of become thinner. See, so you get like, we could try to readjust this a little. Let me just kind of bring this in. See, yeah, I think that looks nice. So it'll be like really thin, and then it'll become thinner or become thicker. Yeah, okay, that looks good. Now, along with this, what we can also try is we have the curve view. So let's also shape this up. Okay, so what I can do is I can take another float, attribute just float, and set it in here. I'll set this to multiply. Okay, and we want to multiply this. We'll do like remap attribute, and this will be curve view. And I will just reshape this. So I'll take it like this, and like, you know, give it like some kind of a leg like shape. Yeah, okay. So you'll get like, you know, this. Yeah, so there you go. So this is your final design. Yeah, let me just visualize the curve view if I can. It looks better with curve view. Yeah, and if you don't want to do a sweep, you can also just do a width. Okay, so what you can do is you can come to object level, turn on like shade open curves. Okay, and then just take a float value, and we will set this to width, and do set always. I'll make it shaded, and do remap attribute, and we will use p scale. So it's now using like the p scale value to like just display, you know, the geometry, except just make it thinner if you want, like, you know, take this value down. Yeah, there you go. And then we can color it. So they can just take a color node. We'll do ramp from attribute curve view. Yeah, turn off the curve view. There you go. And yeah, that's pretty much it. I think this is a little too thin. This one. Yeah, let me just sort of bring this out a bit. Yeah. And depending on how you keep this, like this particular value, so you have like, you know, 2 legs, 3 legs. Yeah, it looks a little better when it has like lesser legs. Okay, or fewer legs, not lesser. Or you can also like, you know, increase the scatter value, so you'll get like, you know, more. Okay, so now let's do the final thing, which is what if you want like multiple spiders? Okay, so it's not very complicated, but let's just do that. Okay, so let me just take all of this. We'll press L. Let's not do the sweep. We'll just keep it with this, with the. Okay, so what I want is I want like particles moving over my sphere, and then we're going to use that for the heads. Okay, so we just need to replace like this one area. So what I'll do is I'm going to take a particle network. So take a pop net, and I'll just connect this in here. And what I want is we want to do a few things. Firstly, I just give it like a relax, and then I want impulse activation, and I want only about let's say 8 points, and this will be like $FF equal to 1. So it's just active for the first frame, right? Like that's it. Okay, the next thing is I want to connect it to the sphere. So just take a pop wrangle, and come to inputs. We'll take the second input and set it to first context geometry. And what you want to do is you want to do like at p, and this is very simple. So just take something called min pos, and we do min pos is the second input. So it's like 0, 1, 2. So that's where the second input is 1, and at p. That's it. Okay, and then take a pop force and just give it some force. So I can just take this, and I can say amplitude is like 2.3, and press play, and you'll get this. Right, like that's it. So they'll just sort of move around. You can increase that. Like let's make it a lot. Let's increase the swirl size as well. Yeah, that's not bad. So we get like, you know, random movement. So this is perfectly fine. Okay, so we're done. And now all you have to do is replace like this path deform stuff with my popnet. So I'm going to take this and bring it in here. So these guys get the normals that they're supposed to. Okay. So we have this, and we can take the peak and move them away. We can probably also delete like a bunch of attributes, because this will have a bunch of attributes, right? So just delete everything. So it just has normals, like it won't have anything else, because it will have like velocity and all of those things. We don't need that. Okay, so you've done this, and now we just want like one point. Okay, and then like, you know, cycle through all of these. So we just need a for each. So just take a for each point, and this comes in here, that goes in there and there, right? And this goes all the way down till here. Let's change the color of this to something else. Yeah, and this comes in here, and if I've done everything right, it should just work. There you go. So if you press play, you have, you know, 8 spiders, and that's pretty much it. So because we are using surface normals, you can use, you know, any geometry that you want to. But as I said, like, because it's not really checking for corners or like if there is a collision here or whatever. If there are points on the other side of the wall, because it's just applying like a radius, it will generate legs going through the wall. Okay, so it will do that. Okay, so I don't care. I never saw, I didn't solve it for that. Okay, but yeah, for like simple stuff, it's perfectly fine. Okay, if you want to apply like more logic to this, I'm pretty sure you can solve that. But you know, homework, you can do that on your own. Okay, yeah, that's pretty much it.